Hi, I'm Johnester Maniego, and I'm here to show you my calculations in determining the value of eigenfunction of 7I orbital given orbital angular momentum quantum number -2 and spin angular momentum quantum number -2. So first, write the given. N equals 7, L equals 6, and M equals -2. First, we calculate for the value of theta. Theta equals parenthesis sine squared theta raised to m over 2 summation of aj times parenthesis cosine theta raised to j limit from 0 to L minus absolute value of m. So, substituting the value of the given, we will get theta equals parenthesis sine squared theta raised to 2 over 2 times a0 plus a2 cosine squared theta plus a4 cosine 4 theta. So, we need to convert the a2 and a4 to a0 by using the recursion relation formula. The recursion relation formula is j plus 2 equals j plus parenthesis j plus absolute value of m times parenthesis j plus absolute value of m plus 1 close parenthesis minus L times L plus 1 over j plus 1 times j plus 2 times aj. So first, if j equals 0, a2 equals 0 plus 2 times 0 plus 2 plus 1 minus 6 times 6 plus 1 over 0 plus 1 times 0 plus 2 a0 equals 6 minus 42 over 2 equals negative 36 over 2, which is negative 18. So the value of a2 is negative 18 a0. Next, when j is 2, so a4 equals 2 plus 2 times 2 plus 2 plus 1 minus 6 times 6 plus 1 over 2 plus 1 times 2 plus 2 a2 is equal to negative 11 over 6 a2. Then we substitute the value of a2 to the value of a4, which is negative 11 over 6 a2. So we substitute the negative 18 a0 to the a2. We will get a4 equals positive 33 a0. So now we have the value, we have the equation theta equals sine squared theta times a0 minus 18 a0 cosine squared theta plus 33 a0 cosine to the fourth theta. So next, we will extract the a0 resulting to theta equals a0 sine squared theta times 1 minus 18 cosine squared theta plus 36 cosine to the fourth theta. So next, we normalize the theta to get the value of a0. So 1 equals integral from 0 to pi theta times sine theta d theta. So we will get 1 equals a0 squared kasi ilalabas na natin yung constant. So naging a0 squared times integral of sine squared theta squared times 118 cosine squared theta plus 33 cosine to the 4 theta squared sine theta d theta from 0 to pi. So first, we will expand the sine squared theta. We know sine squared theta equals 1 minus cosine squared theta, leaving the new equation to 1 equals a0 squared integral of 1 minus cosine squared theta squared times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta squared sine theta d theta. So, since sine theta equals negative d cosine theta, we can now substitute the new value of sine theta to the equation. Leaving the new equation, 1 equals negative a0 squared, integral of 1 minus cosine squared theta squared times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta squared d cosine theta. Since now we will expand the 1 cosine squared theta squared which is equal to 1 minus 2 cosine squared theta plus cosine to the 4th theta. Now we will substitute the new value of 1 minus cosine squared theta to the equation. We will now have 1 equals negative a0 squared, integral of 1 minus 2 cosine squared theta plus cosine to the 4th theta times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta squared d cosine theta. Now we will expand the 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta squared. We know that x plus y plus z squared is equal to x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz as written on the mathematics formulas and definitions of Jimmy C. Chan. Now expanding the equation will give us 1 plus 324 cosine to the 4th theta plus 109 cosine to the 8th theta minus 18 cosine squared theta plus 33 cosine to the 4th theta minus 594 cosine to the 6th theta. So we're combining the like terms. Now we will have the new value of 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta squared is equal to 1 minus 18 cosine squared theta plus 357 cosine to the 4th theta minus 594 cosine to the 6th theta plus 189 cosine 8 theta. Now, we will substitute the new value of parenthesis 1 minus cosine squared theta plus 33 cosine to the 4th theta squared to the equation. Leaving the new equation 1 minus negative a0 squared integral of 1 minus 2 cosine squared theta plus cosine to the 4th theta times 1 minus 18 cosine squared theta plus 257 cosine to the 4th theta minus 594 cosine to the 6th theta plus 1089 cosine to the 8th theta d cosine theta. Now we will multiply the two parentheses and it is 1 minus 18 cosine squared theta plus 357 cosine to the 4th theta minus 594 cosine to the 6th theta plus 1089 cosine 8 theta minus 2 cosine squared theta plus 36 cosine to the 4th theta minus 714 cosine to the 6th theta plus 188 cosine to the 8th theta minus 2178 cosine to the 10th theta plus cosine to the 4th theta minus cosine 18 cosine to the 6th theta plus 357 cosine to the 8th theta minus 594 cosine to the 10th theta plus 1089 cosine to the 12th theta. Combining the like terms, we will get now the new value of two parentheses multiplied two parentheses, which is 1 minus 20 cosine squared theta plus 394 cosine to the 4th theta minus 1326 cosine to the 6th theta plus 2634 cosine to the 8th theta minus 2772 cosine to the 10th theta plus 1089 cosine to the 12th theta. Now we will substitute this to our equation. We we now have the equation 1 equals negative a0 squared integral of 1 minus 20 cosine squared theta plus 394 cosine to the 4th theta minus 1,326 cosine to the 6th theta plus 2,634 cosine to the 8th theta minus 2,772 cosine to the 10th theta plus 1,089 cosine to the 12th theta d cosine theta from 0 to pi. Now, we are ready to integrate the equation. So, we will now separate the terms. Yes, the terms. We will now have 1 equals negative a0 squared bracket integral of d cosine theta minus 20 integral of cosine squared theta d cosine theta plus 294 integral of cosine to the 4th theta d cosine theta minus 1,326 integral of cosine to the 6th theta d cosine theta plus 2,634 integral of cosine to the 8th theta d cosine theta minus 2,772 integral of cosine to the 10th theta d cosine theta plus 1,089 integral of cosine 12 theta d cosine theta. Yun. So, pag inintegralan sila, ito na yung lalabas. 1 equals negative a0 squared bracket cosine theta minus 20 over 3 cosine cube theta plus 394 cosine to the 5th theta over 5, 1,326 over 7 cosine to the 7th theta, 2,634 over 9 cosine to the 9th theta, 2,772 over 11 cosine to the 11th theta, plus 1,089 cosine to the 13th theta from 0 to pi. Now we will substitute the limits. 1 equals negative a0 squared, negative 1 minus 1 minus 20 over 3 times negative 1 minus 1 plus 394 over 5 times negative 1 times negative times negative 1 minus 1 minus 1,326 times 7 times negative of 1 minus 1 plus 2,634 over 9 times negative 1 minus 1 minus 2,772 over 11 times negative 1 minus 1 plus 1,089 over 13 times negative 1 times minus 1. So, pag sinolve mo yan, lalabas is 1 equals negative a0 squared negative 7,408 over 455. So, mawala na yung negative kasi may negative tayo sa negative a0 squared tsaka negative dun sa nasolve natin. So, ililipat natin yung a0 sa kabila tapos i-square root natin siya. So, value ng a0 ay square root of 455 over 7,408. Then, pwede pa natin ilabas yung 16. Square root ng 16 ay 4. So, a0 equals 1/4 square root of 455 over 463. Isa-sub natin siya sa value ng theta. So, ang value ng theta natin ay theta equals 1/4 times 445 over 463 sine squared theta times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta. So, next, i-determine naman natin yung value ng R. R and LR equals R raised to L times E raised to negative ZR over NA summation of B sub J times R raised to J from 0 to N minus L minus 1. So, pag sinave natin yung value ng L at N, makukuha natin yung bago nating R7, 6, R equals R raised to 6, E minus negative ZR over 7A B sub 0. So, ino-normalize natin yon para makuha yung value ng B0. 1 equals integral of R times R squared dr from 0 to infinity. So, bago natin equation ay 1 equals B0 squared integral of R raised to 6 e raised to negative ZR over 7A squared R squared dr. So, i-squared natin yung squared natin nasa loob na term. So, 1 equals B0 squared integral of R raised to 14 e raised to negative 2 ZR over 7A dr limit from 0 to infinity. Using the table of integrals from mathematics formulas and definitions of Jimmy C. Chan, given is integral of from 0 to infinity of x raised to n times e raised to negative alpha x dx is equal to n factorial over n a raised to n plus 1. So, kapag ginamit natin yung formula na yon, bali yung magiging x natin yung r, tapos yung alpha na yon, nakita nyo diba sa may table of integral yung alpha. Pag naka-equal siya dun sa a, yun yung a. Tapos yung magiging value ng alpha natin is 2z raised to 7a. So, yung bago nating lalabas na equation is 14 factorial over 2z over 7a raised to 14 plus 1, which is 15. So, solving for the value itself, so we now have 1 equals b sub 0 squared bracket 14 factorial times 7 over 2 raised to 15 times a over c raised to 15. So, yun, isolve natin yan. Pagka-solve natin, nililipat natin sa kabila yung value nung ma-solve natin. Tapos, i-square root natin para makuha natin yung value ng BO. Ang value ng BO natin ay 2.8137 times 10 raised to negative 10 z over a raised to 15 over 2. So, isasolve natin siya dun sa R natin kanina. So, ang R natin ngayon ay R76 R equals 2.8137 times 10 raised to negative 10 times C over A raised to 15 over 2 R raised to 6 E raised to negative ZR over 7A. Next naman, isasolve na natin yung value ng phi. Phi is equal to 1 over square root of 2 pi times E raised to IM phi. Yon. So, yung value natin ng phi ay 1 over square root of 2 pi times e raised to 2 I phi. And kapag negative naman yung 2 natin kasi nga dalawa, so 1 over square root of 2 pi times e raised to negative 2I phi. So next, we will combine the value of theta, the phi, and the r. So we will have now the eigenfunction psi 7, 6, negative 2 is equal to 1/4 raised to 455 over 463 sine squared theta times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta times 2.8137 times 10 raised to negative 10 times z over a raised to 15 over 2 r raised to 6 e raised to negative z raised to negative zr over 7a times 1 over square root of 2 pi times e raised to negative 2I phi. And the eigenfunction psi 7, 6, positive 2 is equal to 1/4 square root of 455 over 463 times sine squared theta times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta times 2.8137 times 10 negative 10 times z over a raised to 15 over 2 times r raised to 6 times e raised to negative z over r over 7a times 1 over square root of 2 pi times e raised to negative 2I phi. Now, we will calculate the value of n by doing the LCAO, LCAO, the linear combination of atomic orbitals. So, psi equals psi 76 negative 2 minus psi 76 positive 2. Now we normalize it. So 1 equals integral of psi times psi d tau. So 1 equals integral of parentheses psi 76 negative 2 minus psi 76 positive 2 times psi 76 negative 2 minus psi 76 positive 2 d tau. We distribute the psi 762 negative 2 to the other term. So now we will get 1 equals integral of psi 76 negative 2 psi 76 negative 2 minus psi 762 psi 76 negative 2 plus psi 762 psi 762 minus psi 76 negative 2 psi 762. So in Kronecker delta, if the I is not equal to j, the value is 0, and if I is equal to j, the value is 1. So in our case, we will now have 1 equals n squared times 1 minus 0 plus 1 minus 0. We will get 1 equals n squared times 2. So the value of n equals 1 over square root of 2. So include this value of n in our equation, leaving the new equation psi eigenvalue psi eigenfunction is equal to 1 over square root of 2 times 1/4 square root of 455 over 463 sine squared theta times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta times 2.8137 times 10 negative 10 times c over a raised to 15 over 2 r raised to 6 and times e raised to negative z r over 7a times 1 over square root of 2 phi parenthesis e raised to negative 2I phi minus e raised to 2I phi. Next, using the Euler's relation, e positive negative I phi is equal to cosine phi plus or minus I sine phi. So the e raised to negative 2I phi is equal to cosine 2 phi minus I sine 2 phi. And the e positive 2I phi is equal to cosine 2 phi plus I sine 2 phi. So if we subtract the e raised to 2I phi to the e raised to negative 2I phi, we will have cosine 2 phi minus I sine 2 phi minus cosine 2 phi minus I sine 2 phi. So makakancel yung cosine 2 phi. Maiiwan na lang is negative 2I sine 2 phi. So we normalize, to remove the r, we normalize it. So yun. 1 is equal to I times I dito. So I squared equals 1. So cancel na yung I. So our new eigenfunction is I square root of 2 times rather 1 over square root of 2 times 1 over square root of 2 pi times negative 2 sine 2 phi times 1/4 times raised square root of 455 over 463 times sine squared theta times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta times 2.8137 times 10 to negative 10 raised to 10 negative 10. Then times to z over a raised to 15 over 2 times r raised to 6 times e raised to negative ZR over 7A. To further simplify our equation, we combine yung mga bagay na kaya pa i-combine. Yan. So, the value of eigenfunction of 7I orbital given ml equals -2 and ms -1/2 is psi is equal to beta times negative sine 2 phi over 4 square root of pi times square root of 455 over 463 times sine squared theta times 1 minus 18 cosine squared theta plus 33 cosine to the 4th theta times 2.8137 times 10 raised to negative 10 times c over a raised to 15 over 2 times r raised to 6 times e raised to negative z r over 7a. So, thank you for tuning.